Hello, my name is Xiaohui Zhou. I'm a principal engineer at Slipstream. Today, I'm going to give a short presentation about a ESTCP project on demonstration of tiered trim and response method. First, I will introduce what this demonstration is about and why static pressure reset saves energy. Following that, I'm going to talk about methodology and objectives of this ESTCP demonstration. We'll take a look at the retrofit process and how the data was collected. And finally, I'll present the key results. This project is about demonstrating an advanced control strategies to reduce fan energy. This advanced controls is applicable to variable air volume system, air handling unit, and rooftop unit with direct digital controls. Traditionally, an air handling unit or rooftop unit uses fixed static pressure control, but ASHRAE 90.1 now requires air handling unit static pressure to be reset through trim and response method. This project is demonstrating tiered trim and response method compared with this fixed static pressure control. First, let's take a look at why static pressure reset saves energy. Let's look at the chart, percentage of airflow versus percentage of fan power. In a typical VV system design, the fans are designed based on the maximum cooling load, and the supply fan need to run at a certain static pressure set point. In this example, the green curve represents the percentage of airflow versus percentage of fan power under 1.5 inches of static pressure. But the maximum design cooling load may only happen a couple of days a year. Most of the time, the fan will run at partial load conditions, and at partial load conditions, the fan power can be greatly reduced if the static pressure can be reset lower. For example, at 50% of airflow, if the air handling unit static pressure is set at 1.5 inches, the fan power is around 28% of full power. But if we can reduce the static pressure to about 0.5 or lower, the fan power can be greatly reduced. That's the difference between the point A and point B in this chart. In this project, tiered trim response method was used to reset the static pressure. The methodology for this demonstration is comparing fixed static pressure method versus tiered trim response method using sequential testing. Basically alternate the control schemes every 2 weeks. And one of the key measures is supply and return fan energy. The key objectives for this demonstration include 30% reduction on AHU or rooftop unit fan energy and less than 1 year simple payback and no additional user complaints or discomfort. In this project, the demonstration had been conducted at 5 sites. These 5 sites are all Iowa Army National Guard facilities. Site number 1 is the Joint Forces Headquarters for Iowa Army National Guard. This is a large commercial building with about 237,000 square feet, 6 air handling units, and 121 VEV terminal units. The building automation system is Dispatch Control's ECNet series. Site number 2 is Muscatine Armed Forces Reserve Center, 3 rooftop units with 36 VV terminal units. The building automation system controls is Johnson Controls Metasys. Site number 3 is Waterloo Army Aviation Support Facilities. This facility has about 34,000 square feet, 1 rooftop unit with 14 VV terminal units. The building automation system is also Johnson Controls Metasys. Site number 4 is Boone Armory. This facility has 77,000 square feet, 2 air hand units with 65 VV terminal units. This facility is controlled by Train's Tracer Summit building automation system. And the last site is Des Moines Military Entrance Processing Station with 28,000 square feet, 1 air handling unit, and 34 VV terminal units. The control system is Invensys IA series. The retrofit is mostly involved with software customization. First, we provide the tier trim response method specification and control sequences to local contractors. Based on these control sequences, local contractors provide quotes for these control retrofits. For a constant volume system, you do need to add VFDs to these supply fans to change it from constant speed control to variable speed control. Here are some photos of the VFDs at these sites. We added power monitoring equipment on these VFDs to monitor supply and return fan power. Again, the retrofit mostly involved customizing the existing building automation system program. The customization of these control programs were done by local building control contractors following the tiered trim response specification provided. The research team also provided functional test form to these control contractors. The control contractors needed to follow the functional test forms to make sure the control sequences were programmed and implemented correctly. Here is an example of a portion of the tiered trim response method program. The tiered trim and response method basically use these temper positions to predict the cooling demand. In this project, we use Hobo data logger with current transducers and watt transducers to collect power data and transmit the data through cell phone network. The data were stored at the manufacturer's clouds first, then we download the data for our data analysis. We also collected some of the building automation system data through trending. The data were collected locally because the control network was separate with the building network. Let's first take a look at a static pressure versus static pressure set point for both fixed static pressure control method and tier trim response method. The blue lines represent the air handling unit static pressure, and the dark red line represents the static pressure set point. First, we ran a week of tier trim response method, then we ran another week of fixed static pressure control method. We can see that during the week of implementing tier trim response method, both static pressure and static pressure set point varied. The range were from 0.4-inch water column to 1.4-inch water column. During the week this fixed static pressure control method was implemented, both static pressure set point and the static pressure not changing much at around 1.4 inches. Now let's look at the fan power comparison for the two different control methods. We alternated the tier trim response method and the fixed static pressure method every day. The green curve represents supply fan power, and the red curve represents return fan power. We can see that for the tiered trim and the response method, the average fan power for the supply fan is about 1.8 kilowatts. And for the fixed static pressure control, it's about 2.8 kilowatts. Similarly, the average return fan power for the tiered trim and response method was also much lower. For these 5 sites, the annual total fan energy savings ranged from 5.5 kilowatt hours to 27.5 kilowatt hours. The average electricity rates for these 5 sites ranges from 5 cents per kilowatt hour to 10 cents per kilowatt hour. And the annual total fan energy cost savings ranges from $300 to about $1,500. The retrofit implementation costs includes hardware capital costs, installation costs, maintenance costs, and operator training costs. For the hardware capital costs, only one site's failed VFD need to be repaired, which costs about $799. And the installation cost is basically the program customization cost. And the maintenance cost is troubleshooting and repair some of the VVBox problems. We also provided operator training to the facility managers because they are not familiar with the static pressure reset strategy. And the total retrofit implementation cost is between $1,600 to $10,000. Why the retrofit implementation costs varied so much? The factors include control contractor's labor rate, the number of VEV terminal units, the quality and stability of the building control system hardware and software, and if the mechanical system was properly designed and operated. This table shows the cost effectiveness of this control strategy. Among the 5 test sites, the simple payback ranged from 1.7 years to about 15 years. In 3 of the 5 sites, the simple paybacks were less than 5 years. This table shows the projected annual energy savings per square feet. And on average, the fan energy savings is about 0.13 kilowatt hours per square feet. Here's the summary of this ESTCP demonstration. Static pressure reset is required by ASHRAE 90.1 for a variable air volume system with zone level control. Only custom programming changes are needed for a VV system, and you need to add VFDs if converting from a constant air volume system. Simple payback can be from 1.5 years to 10 plus years, depending on the existing building condition and other factors. Hiring a qualified controls contractor with reasonable labor rates is the most critical factor. The most common problem implementing static pressure reset is the rogue zones. Rogue zones are the zones that with VV dampers always at the maximum damper position. This could be due to design error, it could be due to a sensor error. These rogue zones need to be fixed or ignored for this control strategy to be effective. This is the end of this short presentation. Thanks for watching.